Okay, yeah, so I'm Anthony. I'm working with Then Try This, which is a non-profit organization that specializes in technology R&D for projects with kind of environmental and social purposes. And the project I'm talking to you about today is called Smog Off, which is where we're developing low-cost open source air pollution sensors. And kind of the aim of this project is to improve accessibility to reliable air quality monitoring equipment and reliable air quality data. Oops. So poor air quality threatens both health and climate. So in 2016, the World Health Organization estimated that ambient air pollution causes around 4 million premature deaths each year worldwide. And sources of air pollution are also sources of greenhouse gases, which contribute to climate change. And there's two particular pollutants that are of particular concern for human health. So first is particulate matter, which is a mixture of solid and liquid particles that's suspended in air. And they're categorized by their size usually. So you have PM10, which is particles that are less than 10 microns in diameter, and PM2.5, which is particles less than 2.5 microns in diameter. And these smaller fine particles particularly penetrate deep into the lungs and cause cardiovascular disease, respiratory disease, and lung cancer. And another significant pollutant for humans is nitrogen dioxide, which can trigger asthma, cause lung inflammation, and reduce lung function as well. And you have others such as ozone and sulfur dioxide and things like that, but these two have been implicated in kind of detrimental effects to human health. And the World Health Organization recently lowered their guideline levels of these pollutants in order to protect more people against the health impacts of air pollution. So there's currently a range of equipment available for monitoring air pollution. And the first is reference stations. So these are large static stations that continually monitor air pollution in one location. And they tend to be used by governments to identify long-term trends and for compliance. And so the ones pictured here are DEFRA's automatic urban and rural network stations. And there's around 200 of these nationally. And they contain equipment that costs kind of tens of thousands of pounds. And you can get smaller ones, so they're these portable monitoring stations that are commercially available, and these can be placed anywhere. They can be put on a lamppost or a fence by a road, so they're better for kind of more local air pollution monitoring. But the ones pictured here are still very expensive. They're sort of between £2,000 and £10,000. And recently there's been more availability of wearable sensors, so you can get these small sensors that you can kind of put onto a bike or wear on a rucksack, and they allow you to fine scale map air pollution data as you take journeys. So if you're traveling to work or on a cycle ride or something, and they're more affordable at around £200, these ones that are pictured, but it's not clear yet how reliable the data they collect is. And an issue with all of these examples is that they are based on proprietary technology. So by that I mean that the hardware and software is owned by a company, and it's often difficult to access the information on what components they use and how exactly they process the data. And there's also a growing number of citizen science projects that offer build-it-yourself kits, sensor kits for, and these use low-cost components. And then these projects build networks of sensors that are put out by citizens. And this contributes to mapping air pollution over larger spatial scales. But there's currently little information about whether the data collected by these low-cost devices are actually reliable and whether they've been properly calibrated. So the kind of aim of the Smog Off project is to develop a low-cost sensor, but importantly also collects reliable air quality data. So just before I get into the sensors themselves, just wanted to talk a little bit about the history of the project and how it came about. So it kind of all started with a project called the Sonic Bike project, which was a collaboration between Then Try This and the sound artist Kath Matthews. And this was essentially a bike that it plays music and sounds as that changes depending on where you ride and how fast you ride. And this used a GPS mapping system, which was designed by Then Try This. And they realized that you could use similar technology combined with environmental sensors for mapping and sonifying environmental data in real time. And as there's little fine-scale environmental data from marine environments available, they decided to put this system on kayaks. And that's where the Sonic Kayak project was born. And Sonic Kayaks was a project that started from open workshops, so it was very much a citizen-led project from the very start. So this is a schematic of the Sonic Kayak system. So it basically contains a GPS for mapping the location of the kayak, and then a range of environmental sensors. So you have a thermometer, a turbidity sensor for measuring cloudiness of the water, a hydrophone for measuring underwater noise pollution, and a particulate matter sensor for measuring air pollution. And then all those sensors feed back into a central computer, and then that process is processed into sound, which is played back to the paddler of the kayak. And this system was tested in the Falmouth estuary in 2020 after the kind of first lockdown was over. And around this time, there was this large cruise ship docked in Falmouth docks, which just was left with its engines running continually. I think they were doing maintenance on the ship with no passengers. But it was kind of thought that this was pumping out lots of pollution into the estuary, air pollution. So this is a map of one of the Sonic Kayak journeys around the estuary at that time. So the hexagons show the kind of location of where the kayak was going, and if they have a purple fill, the air pollution levels are low, and the more kind of blue and yellow they are, the higher the air pollution levels. Let's see if I've got a laser pointer here just to show you. So the ship in the dock was around here. So it kind of upwind of the ship, there was kind of evidence of higher levels of air pollution. And this image was posted on Twitter, and it generated a lot of interest from people. So there was a local councillor and a sustainable transport group that asked whether it'd be possible to also map air pollution on land as well, and around Falmouth. And then that kind of led into a application for SmartLine funding, which was awarded last year, to develop a low-cost air pollution sensor for use in kind of urban areas. And that's around the time that I got involved with the project. So now I'm just going to run through kind of what the first prototype of this system looked like. So it's based on Arduino microcontrollers, which are kind of small computers about the size of a credit card. And it had you can use these computers to program hardware components. Had an SD card interface so that all the data would be read to an SD card, and it's powered by rechargeable batteries. And we had two sensors. So we had a particulate matter sensor and a nitrogen dioxide sensor. And there's also a separate, smaller Arduino computer which processes the data and powers a visualization, a data visualization, which is in the form of a kind of LED matrix. So all in all, this system costs around £200, but around 50% of that cost is the nitrogen dioxide sensor. So if you just have the particulate matter sensor instead, it's around £100. And the system is fully open source, so it means it's free to use, distribute, and modify according to anyone's needs. And we have an open repository on GitLab where all the data code and documentation is available. So we built a couple of prototypes and we housed them in these weatherproof boxes with these kind of plumbing pipes coming off the top of them to allow airflow over the sensors. And we initially just built 2 prototypes with different data visualization techniques. So one of them was just a ring of LEDs which visualize both particulate matter and nitrogen dioxide separately. And another one was kind of a more simple design which had a LED matrix which just showed a smiley face if air pollution levels were low, a sad face if they were high. And we tested these out outside our studio and noticed cyclists were stopping to have a look at them. And yeah, so these visualizations seem to be good for engaging people in what we're doing. So we ran a few tests just to see how well they worked. So this plots from a test outside on a busy road in front of our studio in Penryn. So we've got time on the x-axis and pollution level on the y, and the green line is nitrogen dioxide, and the blue line's particulate matter. The horizontal straight lines are the World Health Organization limits for 24 hours. So it just showed that we were getting kind of fluctuations in air pollution as you'd expect, and that these were higher than the World Health Organization limits. And then the next day we tested the same from the studio next to an estuary, so it's away from the busy road. And this just kind of showed that sensor was producing sensible data, so it's lower pollution levels on that side. We then made just a few more tweaks to the system. So we added a temperature sensor because we realized that the nitrogen dioxide sensor was sensitive to ambient fluctuations in temperature, so that we just built into the software some algorithms that correct for that. And then we also just made a few tweaks to the software just to increase the battery life. So we had data from these initial tests showing that the sensors worked, but we didn't know how well they represented actual pollution levels on the road and on the estuary. So an important next step was to run co-locations with our sensor against Cornwall Council reference stations. So we did this in Truro. We had attached one of our sensors to a lamppost about 1 meter from a reference monitor and left it there for 36 hours. And we found that we have quite good agreement between our sensor and the reference monitor. So here we've got PM10 concentration, and the blue line is the 15-minute mean of the smog-off sensor, and the black line is the 15-minute mean of the reference monitor. And yeah, basically the pattern shows good agreement, but the absolute values don't match quite as well. If we just look at the instead of the 15-minute mean, we change it to 15-minute maximum of our smog-off sensor, we get much higher agreement. So there's ways to kind of tweak the data processing so that it matches really well with the reference station. And for NO2, it wasn't quite as well matched, but it wasn't too far off in some places. So we have peaks that kind of broadly match. But the plan is to now explore some algorithms that will help match our data a bit more closely to these reference stations. So yeah, so some next steps. Yeah, so we're going to look at some algorithms to so that the data matches more closely to the reference equipment. We also want to develop a web app so that people can interact with data online through visualizations and explore the data collected by these sensors. And also going to work on the housing design to make it a more streamlined, easy to use design. And we basically want these sensors to be used as accessible to people as possible. and available to anyone who wants to collect air pollution data locally. So there's some potential uses that would be good. So kind of would be good to use them in schools. You can have them set up on a school fence kind of around the time of the school run to kind of measure air pollution there. Other options are kind of outdoor spaces, so parks near busy roads. So there's one in Penryn Park, which is right next to Commercial Road, and I think they're putting up an ivy barrier there at the moment, and they basically there's no evidence to say that whether that's actually going to improve air quality on the park. So places like that would be a useful place to put these. And the fact that these sensors have these data visualizations has the potential to kind of encourage active transport. If people are seeing that we've got high levels of pollution in certain locations, it might change people's behavior. And very recently, there's been new funding announced for a cycle route between Falmouth and Penryn. And currently I'm talking to people at Cornwall Council to measure air pollution using these sensors kind of before and after the cycle lane is implemented, to see if it has any effect on air pollution locally. So I'd just like to thank Amber and Dave, who are the directors of Then Try This, and obviously been instrumental in this project, and Jo Garrett from ECHH for her contributions to the Sonic Kayak project and also Smog Off. Thank you, that's the end of the presentation.
Thank you, Anthony. That's brilliant. We have a statement from Ellie that just said this needs to be everywhere, and then we can see and make real-time changes to better protect the environment. And we do have a question from Belinda, who says internal air quality, particulate matter, is one aspect being monitored by the SmartLine project, where research is exploring the impacts of the home internal environment on health and well-being. Have you used your external prototypes for internal monitoring? Also, how long does your battery last for?
We haven't used them yet for internal monitoring, but there's no reason why they couldn't be used for that. And yeah, the battery life currently it's around 30 hours, but there are ways to kind of improve that. So it could yeah, it just depends on which types of battery you're using and how the sensor's set up, how the software's set up. So yeah, if you kind of stripped it back a little bit and you only measured particulate matter, for example, you'd be able to increase the battery life. But yeah, does that answer those questions?
Yeah, thank you. And I think Sam was holding up something, an image. So I don't know whether you wanted to share what you were holding up, Sam.
So it's the benefit.
No, it was only my my air quality monitor.
Oh, nice.
But these ones are often used outside as well. But they're sort of 200 to 300 pounds for outdoor suitable ones. I was just wondering why what the advantage of developing your own hardware was over using the sort of 300 pound units that are available.
Yeah, so I guess like the main advantage that you can really understand how the data is being processed, because a lot of the time yeah, these kind of handheld ones, you get yeah, there's not much information about how exactly they're smoothing the data. If you look at the data for a lot of these things, they seem very smooth, and it's kind of not exactly how you'd expect the fluctuations to be. So I think it makes it more transparent how they work, and what algorithms are being used to kind of smooth the data, I guess.
Yeah,
and it also makes it customizable, so you can change it as you want to, according to your needs.
Yeah, and you have full access to that, because the IQ Air one that I use, and then there's the Purple Air as well. They're both approved for use on the United Nations Environment Programme World Air Quality Map. So I guess that's something that you could look to as well to get yours approved, to be able to add that onto the UNEP Global Air Quality Map.
Yeah, cool. Yeah, I'll look into that. Cheers.